I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken up a very interesting question based on harmonic motion. Now, it's an important question on trigonometry, especially for IB and AP math students. Well, let me thank all the viewers and subscribers for supporting our channel, which has been there for 15 years, absolutely free, and now with more than 17,000 videos. Contribute generously so that we can reach millions. Perfect. So the question is there before you. You must have read it by now. I would like you to pause the video, answer this question, and then we'll look into its suggestion. Well, the question here is f of x is given to us as 12 cos x minus 5 sin x. The function of f(x) can be written as a cos x plus p. So you need to find the value of a and p. Okay. Once you do that, you have to find the range of this function. And then part B is interesting. It says find coordinates of maximum and minimum values of the function in the interval minus pi to 2 pi. Extremely important question. Let us see how do we do it. And at the end of the solution, I'll also give you a shortcut that will really help you to answer these questions in the minimum time. Well, in case you want to learn directly from me, feel free to send an email on the address given. We call this equation as a harmonic wave equation. So we are given a function which is f of x equals to 12 cos x minus 5 sin x. And what we need to do is to write it in terms of f of x equals to a cos x plus p. So let us expand the second equation which gives us a, and applying the compound angle formula, we can get this as cos of x cos of p minus sin of x sin of p. Well, if you compare all first and the second equation, you can definitely find the value of cos p and sin p. Well, it cannot be more than 1, right? So how could I relatively write down the first equation? Key here is that, 12 and 5, they're more than 1, right? So what we do here is that we divide both sides, the whole thing. We take something common, right? And then do it. So we call this, we can say that a, let me just tell you, a will be equal to square root of 12 square plus 5 square, right? So 12 square plus 5 square is what the value of a will be taken as, which is 144 plus 25, with square root of 169, which is 13, right? So if I write a as 13, in that case, I could rewrite f of x. Let me show you how. So f of x can now be written as, I'm taking 13 as common, right? So in that case, what happens? The equation now becomes what? 12 over 13, right? Cos x minus 5 over 13 sin x. Does make sense to you, right? That makes sense, right? You can correlate this with a triangle. Now, this is a concept, okay, which helps you to solve such questions. If this angle is P, then cos is 12 over 13, right? That's a special triangle, right angle triangle, and sine is 5 over 13. Is it making sense to you? Right? So that is how you actually do it. And so we know the value of A now should be 13, right? Now, how do we find the value of P? Now, the value of P can be found very easily. We can say that tan P is equal to what? Well, tan p is 5 over 12. So that implies that p is equal to tan inverse of 5 over 12. So it's in radians, mind it, it's in radians. So we'll switch the mode to radians and then find shift tan inverse of 5 divided by 12. What do we get? So on my calculator, I get a value 0.394. So 3947. So I could actually round it to 0.395. Makes sense? So that becomes the value of P. And therefore, I can actually write the expression f of x as equal to 13 times cos of x plus 0.395. Now, sometimes you get this question as a graphing calculator question, right? But you could actually solve it even without graphing calculator. So, do you see that? So, once again, you could actually expand the right hand side and then correlate and get the answer. So, that is how you get the equation. Now, let me rewrite the equation which we got. So, we got f of x as equal to 13 times cos of x plus 0.395. So once you have this equation, you can answer part B, right? Which is find the coordinates of maximum and minimum during the period from minus pi to 2 pi. Very interesting question. So part A, we already got A is equal to 13 and P is equal to 0.395, right? Now to get the maximum minimum, let's try to understand the equation which is at hand, right? So basically, it's a cosine graph. So let's say we graph it like this, right? Okay. So what we are saying is that the maximum is 0.395 before x, right? So kind of like this. The axis is right there from the center, and therefore the first maximum, which is on the left side, so from minus pi, we are saying, is at 0.395. So we see that the maximum is at minus 0.395 and the value of course is 13, right? The minimum is right there and which will be at minus 13, right? So minimum is right there. And what is the period? Well, we know that the period is 2 pi, right? The function repeats after 2 pi, as you can see. So if I add pi to this, I will get the minimum value. So 0.395 plus 3.14, I'm just adding. So 3.535 I get. So minimum value will be at 3.535. Let me make it 6. Okay. 535 and the value will be minus 30. And when am I going to get the next maximum, which will be less than 2 pi, right? Because the first is before 0. So we'll add pi more, 3.14. I should add exact value of pi, but I'm just making this. So it is 6.675. So it is at 6.675. And of course, maximum value is 13. Is it making sense to you? So that is how we actually do this type of a question, right? So I hope the concept is absolutely clear. You can always send an email on my email address for doing well and understanding the concepts. We can be part of your success. Now, let me just give you a shortcut method that if you're given a function f of x as equals to anything, let's say uh, capital A cos x minus b sine x, right? In that case, the amplitude A, which we're talking about, will be square root of a square plus b square, And the value of P is going to be tan inverse of B by A. Makes sense. So that gives you the simple harmonic motion formula. So remember that any combination of sine and cosine, as shown here, can be written as a cosine function or even as a sine function for that matter, as we just did. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, it'd be great. Thanks for your time and all the best.